When most people first learn C++, they are taught a sentence. Const means this object cannot be modified. This statement is not entirely correct. It may even lead you to write poor interfaces. In C++, const doesn't care about whether the object will change, but about what you are allowed to do. In other words, const is a promise to the caller, not a physical restriction on the object's internal state. Let's first look at a familiar scenario. Define a counter struct with a value variable, and then write an increment function decorated with const. A compilation error occurs directly. This is the expected result. What happens if we add the mutable keyword to value? No error this time. However, value is clearly modified, and for the caller, increment function is still that const member function. Therefore, const in C++ is not equivalent to immutable at all. Its true meaning is, from the perspective of the interface, this operation will not change the object's logical state. Let's take a simple example. When you buy milk tea at a milk tea shop, the taste and portion of the milk tea are the logical state you care about, while the order counter in the clerk's background is the physical state of the milk tea shop. For you, when the clerk increments the counter by 1 while taking the order, you don't perceive it at all. This is unchanged logical state. Corresponding to C++, this is what the const function promises. And the modification of the counter's physical state needs to be marked with mutable. If you still regard const as a simple anti-modification tool, until now, your API design is probably problematic. For example, a query function that should be marked as const is not marked as const because it needs to modify an internal cache, or arbitrarily using const_cast to bypass restrictions, which ultimately causes the program to crash.